Welcome back, explorers of the unknown, to the Space and Astronomy podcast. Today we're embarking on, well, a truly mind-bending deep dive. We've gathered insights from a whole stack of fascinating sources, scientific papers, deep philosophical text, even some ancient wisdom traditions. And our mission, like always, is to really dig in and pull out the most crucial nuggets of knowledge. The goal is to help you get quickly up to speed on a topic that seriously challenges how we understand reality itself. And wow, what a topic it is. We're tackling one of the most profound, maybe even disorienting questions humanity has ever really grappled with. Is time an illusion? It's just a construct shaped not only by the cold, hard laws of physics, but maybe by the very nature of our consciousness. And I know what you're probably thinking. Time feels so incredibly real, so fundamental. I mean, think about the relentless ticking of a clock, or maybe just the quiet rhythm of your own heartbeat, or those vivid memories of yesterday and the anticipation, sometimes excitement, sometimes anxiety about tomorrow. Everything we experience, everything we plan, pretty much everything we are, seems meticulously framed by time. It feels like this invisible river we're all just constantly floating down, doesn't it?
It absolutely does feel that way. And that feeling, that deep, pervasive, ingrained sense of flow is exactly why this topic is so captivating and honestly, potentially revolutionary. Because what if? What if that undeniable sense of flow, that relentless march from past to future, what if it's not fundamental, not part of the universe's ultimate reality? What if time, as we actually experience it subjectively, is just how our minds manage to organize everything? A kind of narrative that consciousness tells itself, a grand, continuous story it constructs, constantly weaving together these snapshots into what feels like a seamless past, present, and future, almost, on the fly. It's such a counterintuitive idea, and it doesn't just poke at our basic assumptions. It could fundamentally reshape our entire worldview.
Okay, so if that thought just sent a little shiver down your spine, or maybe made you lean in a bit closer, then you are definitely in the right place. Get ready to have your perceptions nudged, maybe even totally recalibrated. We're going to navigate this really complex territory together. We'll start by grounding ourselves in how physics has traditionally seen time, from the absolute certainty of Newton up to the wild relativity of Einstein. Then we'll pivot. We'll look at the surprising insights coming out of neuroscience, exploring how our brains actively sculpt our sense of time. After that, we'll descend into the, frankly, even stranger world of quantum mechanics, where time seems to behave in utterly bizarre ways. Sometimes it seems to just disappear altogether. And finally, we'll really delve into that profound, intimate connection between time, consciousness, and those age-old philosophical and mystical traditions. It's a journey from the cosmic scale down to the cognitive, and then right back again. So let's dive in. Okay, let's start at what was, for centuries, the bedrock of our understanding, the really intuitive foundation, classical Newtonian mechanics. In Isaac Newton's grand picture of the universe, time was seen as something utterly absolute. Not just a concept, but a real unchanging quantity. Like a universal clock, right? Ticking uniformly for everyone, everywhere.
Exactly. You could almost picture it as this immense, invisible cosmic river, just flowing constantly, steadily, independently. It was completely unaffected by anything else happening in the universe. Didn't matter if objects were moving at incredible speeds or if massive planets were pulling things around with gravity.
So Newton believed every single observer, no matter where they were, no matter how fast they were moving, experienced the exact same constant flow of time. A second here was exactly a second on, say, Jupiter or a distant star. It was the backdrop. Unchanging, universal.
And that model was incredibly powerful. It felt right. It worked for describing so much of the world we could see and measure. It held sway for over 200 years. It really defined what we thought time was. Until Albert Einstein arrived on the scene. And with his theories of relativity, he didn't just tweak the picture, he fundamentally shattered that elegant, intuitive Newtonian view. It was a radical redefinition, showing time and space weren't separate things at all, but deeply interwoven.
Right, space-time.
Exactly. Let's start with special relativity back in 1905. The core idea was just earth-shattering. Time is absolutely not constant. It's relative. In fact, it actually slows down the faster an object moves relative to someone else watching it. It's called time dilation.
Okay, time dilation. Can you give us a way to sort of visualize that? Because it's hard to get your head around.
Sure, let's try a thought experiment. Imagine we have two perfect, identical atomic clocks synchronized right down to the nanosecond. One clock stays right here on Earth, just ticking away. The other, we put on a super fast spaceship. Let's say it blasts off and travels at, 99% the speed of light for what feels like a year to the astronauts on board.
Okay, high-speed journey.
Right. Now, according to special relativity, when that spaceship eventually comes back and lands, the clock on board, the one that traveled, will actually show less time has passed compared to the clock that stayed on Earth. For the astronauts, maybe only a few months went by, but for us back here, a full year, maybe even more, could have elapsed.
Wait, so it's not just that it feels slower for them, it's an actual measurable physical difference.
That's the crucial point. Exactly. It's not subjective feeling. The astronaut inside the ship experiences time perfectly normally from their perspective. Their heart beats normally, they age normally, everything feels constant to them. It's only when you compare their clock, or their biological processes, to a clock that stayed relatively stationary, like the one on Earth, that the objective difference in elapsed time becomes totally apparent.
So different observers moving at different speeds literally experience different amounts of time passing between the same two events.
Precisely. Their now isn't the same now. There's no single universal present moment that everyone agrees on. Your present depends on your motion, my present depends on mine.
That just completely unravels our everyday intuition of a shared moment in time.
It does, and it gets even stranger with general relativity, his later theory.
Right, this is where gravity comes in.
Yes. Einstein showed gravity isn't just a force pulling things together, it's actually a curvature, a warping of the fabric of space-time itself caused by mass and energy. And this warping affects time. The stronger the gravity, the deeper you are in a gravitational well, the slower time ticks.
Okay, so the example our sources gave, a clock on Earth ticks differently than a clock on a satellite in orbit. That's a real thing.
Oh, absolutely real. And not just theoretical, it has very concrete practical implications.
Like what? Is it a big enough difference to matter?
It's essential for things like GPS to work accurately. The global positioning system we all rely on constantly. Those GPS satellites are orbiting Earth pretty fast, around 12,500 miles per hour, and they're also further away from Earth's gravitational pull than we are on the surface.
Okay, so two effects happening there.
Exactly. Special relativity says because they're moving fast, their clocks should run slightly slower than ours. But general relativity says because they're in weaker gravity, their clocks should run slightly faster than ours.
And which effect wins?
The general relativity effect, the faster ticking due to Whitner gravity, is actually the bigger effect. So overall, the clocks on the satellites tick faster than identical clocks on the ground. If engineers didn't constantly account for both of these relativistic effects, the time difference would build up, about 38 microseconds per day.
38 microseconds, that sounds tiny.
It sounds tiny, but for GPS, which relies on incredibly precise timing signals to pinpoint your location, it's huge. That tiny difference would translate into your calculated position being off by several miles within just a few hours.
Wow. Miles. Okay, so GPS would be useless without correcting for relativity.
Completely useless. So yeah, these aren't just abstract ideas, they're baked into the technology that runs our modern world.
That's incredible. It really drives home the point. So recapping this part, what relativity tells us is that time isn't this fixed, universal river Newton imagined. It's relative, it's flexible, it stretches and squeezes depending on speed and gravity. It's woven together with space.
Precisely. Time is much more dynamic, much more interconnected with the physical universe than we ever thought. It's like a landscape with different time flows in different places. But here's the crucial transition point for our discussion. Despite all these revolutionary findings, physics, even relativistic physics, still fundamentally treats time as something real. It's still a dimension, a coordinate in this four-dimensional fabric called space-time. It exists. It's part of the description of reality.
Okay, so even Einstein didn't say time was an illusion, just that it was relative.
Right. So if physics still holds on to time as a real, albeit flexible dimension, the big question becomes, where does this whole illusion idea actually come from? Why are we even asking that question?
And that leads us to some even more radical interpretations, doesn't it?
It does. It leads us directly to a concept often called the block universe theory, or sometimes eternalism. It's a pretty radical interpretation suggested by many aspects of relativity. Try to imagine time, not as flowing at all, not even as these flexible streams, but as something static, complete, fixed. In this view, the past, the present, and the future are all equally real. They all exist simultaneously.
Simultaneously, how does that work?
Think of it like this. All of time, from the absolute beginning, the Big Bang, right through to the universe's ultimate end, maybe heat death, trillions of years from now. It all just is. It's not unfolding. It's already laid out.
Okay, that is a huge shift from how we experience things.
Yeah.
Our sources had a great analogy for this, the DVD one. They said, in a block universe, the universe is like a DVD. Every frame from the Big Bang to the heat death exists simultaneously. We're just experiencing one frame at a time.
That's a perfect analogy. On a physical DVD, all the scenes, every moment, every action, it's all already etched onto the disc. Beginning, middle, end. It's all there. When you press play, your player just moves through those frames sequentially. The story appears to unfold in time, but the entire thing exists fixed on the disc.
So the block universe is like the entire cosmic movie, already finished, just sitting there.
In essence, yes. It implies a profoundly predetermined reality, a fixed cosmic history. Every event that ever happened, is happening now, or ever will happen is already part of this four-dimensional block. There's no real coming into being or passing away. Things just exist at their specific coordinates in space-time.
That completely rejects our gut feeling that the future is open, that we make choices, and that the past is gone forever.
It does, and this isn't just some fringe philosophical idea. It has deep roots in the mathematics of relativity. Hermann Minkowski, who actually taught Einstein math and helped develop the mathematical framework for special relativity, he famously declared back in 1908 something like, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows."
And only a kind of union of the two will preserve an independent reality.
Yeah, I remember reading that. Powerful stuff.
It is. He essentially describes space-time as this four-dimensional block. Time is just another dimension, like length, width, and height. Just like you can pinpoint a location using spatial coordinates, in this block universe, you could theoretically pinpoint any event using its space-time coordinates. Your birth, this conversation right now, the coronation of Queen Elizabeth II, the final moments of the sun.
They all just exist.
Yeah.
Equally real points in this block. According to this theory, yes. Which leads to the mind-bending conclusion, as our source notes. If true, there is no objective now. No special, privileged present moment that slices through the universe for everyone. Every moment simply is eternally present within this vast, static reality.
Okay, but that brings us right back to the core problem, the big paradox here. If reality is this static four-dimensional block where everything past, present, future already exists, then why on earth do we feel like time flows? Why do we experience a distinct past slipping away, a fleeting present, and an unknown future rushing toward us? It feels so real.
Exactly. That's the fundamental tension. The disconnect between the static geometric view of reality suggested by physics and our undeniable subjective moment-by-moment experience of time's arrow.
And that disconnect points us directly towards the role of our own minds, towards consciousness, doesn't it?
It really does. This is where we shift gears dramatically. We move from the vast scales of cosmology and physics right into the intricate landscape inside our own heads. Because according to neuroscientists, our brain isn't just passively recording time like some internal stopwatch ticking off external seconds. Instead, the growing consensus is that the brain actively constructs our sense of time. It weaves it together.
Constructs it how?
It combines sensory input coming in right now, pulls on memories of the past, factors in our expectations of the future, and even uses our internal biological rhythms. From all that, it creates our perception of duration, of sequence, of things happening together or one after another. So our feeling of time passing isn't a direct reflection of some external clock. It's an internal creation. A subjective experience built by the brain.
That makes a lot of sense when you think about it. I mean, look at the work of neuroscientists like Dr. David Eagleman.
Yeah.
He argues that our time perception is incredibly flexible, right? Malleable.
Absolutely. His work highlights this beautifully.
And we all have examples from our own lives. Like when you're in danger, you know, a near miss in traffic or a sudden fall time seems to just stretch out, slow right down.
Yes, the classic slow motion effect.
Right. It feels like you have ages to react. But then think about being bored. Stuck in a waiting room, maybe? Minutes feel like hours. It just drags.
Time crawls.
And the opposite. When you're totally absorbed in something you love, playing music, deep in conversation, maybe coding hours can just vanish. They feel like minutes.
The flow state experience, time just disappears.
Exactly. And maybe the weirdest example Eagleman mentions is dreaming. You can have these incredibly complex, long, epic dreams.
Yeah, whole lifetimes sometimes.
That unfold over what, in reality, is just a few seconds or minutes of actual REM sleep. Our brain can just generate its own timescale.
All these common experiences really hammer home how flexible and context-dependent our internal clock is. It's not rigid. Our brain is constantly adjusting our subjective perception of time based on our emotions, our focus, how new or familiar a situation is, even just our heart rate or adrenaline levels.
So if our brain is basically manufacturing our sense of time, tweaking it based on context, does that mean time itself, the thing we feel passing, could just be a cognitive illusion.
That's the critical question neuroscience forces us to ask. If the brain is the architect of our temporal experience, synthesizing it from raw data and memory, then maybe the experience is the reality for us, but it doesn't necessarily map onto something fundamental outside of us. Our brain does this amazing job stitching together these discrete moments, these snapshots of perception, into what feels like a smooth, continuous movie, a timeline.
Like editing a film, as the source said.
Exactly like editing a film. The editor takes static frames and sequences them to create the illusion of motion and narrative flow. Maybe our brain is doing something similar, taking timeless nows or perhaps just processing information packets and arranging them in a sequence that creates our subjective experience of time flowing forwards.
Wow, okay. So the brain might be the film editor creating the movie of time in our heads.
That's one compelling way to think about it based on neuroscience. And this idea that time might be constructed internally leads us even deeper into the quantum realm.
Right. If we go down to the most fundamental level science can currently probe, the realm of quantum mechanics, things get even more perplexing for time. At the heart of standard quantum mechanics is the Schrödinger equation. It describes how quantum systems, like atoms or electrons, behave. And here's the really weird part. The basic form of this equation doesn't inherently need time to evolve in the way we normally think of it.
It doesn't need time. How can anything evolve without time? Well, it describes the state of a quantum system using something called a wave function, which represents all the possibilities for that system. This wave function exists in a space of potential configurations, not necessarily flowing along a time axis. Time seems to enter the picture more explicitly when we talk about measurement or observation, the moment when all those possibilities collaborate into one definite outcome. So some interpretations suggest time might not be a fundamental backdrop, but something that emerges from these quantum interactions or measurements. It's a consequence, perhaps, not a pre-existing stage.
Okay, that's already pretty mind-bending. And this is where people like Julian Barber come in, right?
Right.
With his idea of timeless physics.
Exactly. Barber is a theoretical physicist who's taken these quantum ideas, particularly in the context of trying to merge quantum mechanics with gravity, general relativity, to a really radical conclusion. He proposes that, at the most fundamental level, time simply doesn't exist. At all.
No time. So what is there?
He suggests the universe is composed of an infinite collection of static moments, which he calls nows. Think of them like individual frames in that cosmic movie, or maybe pages in a photo album, as one source put it. Each now is a complete, unchanging snapshot of the entire universe, every particle, every field in a specific configuration. It just is. A timeless arrangement.
So like infinite frozen moments.
Kind of.
Yeah.
An infinite collection of possible configurations of the universe, all existing simultaneously in a vast space of possibilities he calls Platonia. There's no inherent connection or flow between these nows.
But we feel flow, we experience change. So how does Barber explain that?
This is where consciousness comes back in, crucially. In Barber's view, it's our consciousness that creates the illusion of flow. Our mind somehow samples or experiences a sequence of these static nows, these different configurations, and interprets that sequence as time passing and things changing. So we aren't moving through an external time. Our consciousness generates the experience of time by linking these timeless snapshots together into a story.
So consciousness is like the projector light moving across the static film frames.
That's a pretty good analogy for his idea. It completely reverses the usual picture time isn't fundamental. The experience of time is generated by consciousness interacting with these timeless states.
Okay, wow. And quantum mechanics has other weirdness related to time too, doesn't it? Like entanglement.
Oh, absolutely. Quantum entanglement is one of the strangest and most non-intuitive aspects. This is where two or more particles become linked in a fundamental way. They share the same fate, the same quantum state, no matter how far apart you separate them, even across the galaxy.
And the spooky action at a distance part.
Right. If you measure a property of one entangled particle, say its spin, you instantly know the corresponding property of the other particle. Instantly. There's no measurable time delay for any kind of signal to travel between them, even if they're light years apart. It seems to happen faster than light.
Which should be impossible, according to relativity.
Exactly. It profoundly challenges our ideas about locality, that things can only be affected by their immediate surroundings, and causality, that effects must happen after their causes, respecting the light speed limit. If a change here can instantly correlate with something over there, what does that do to our notion of a strict sequence of events? A causing B later. Some interpretations go even further, suggesting that this non-locality hints that maybe causality itself might be an illusion, not just time. If cause and effect aren't strictly sequential, well, that unravels everything.
Good grief. So between timeless equations and spooky entanglement, quantum mechanics really throws a wrench in our standard picture of time. So if physics at this super deep level, the quantum level, doesn't seem to need time as a fundamental ingredient, if it operates with possibilities and instant correlations, then what does that say about our experience of it?
That's the million-dollar question. What does it mean for us, for our reality, if the bedrock mechanics of the universe might be timeless?
Which leads us squarely into the philosophical deep end, where consciousness and time seem inextricably linked.
Exactly. We've circled back to the philosophical core. We've seen physics describe time as relative, maybe even emergent or non-existent at the quantum level. We've seen neuroscience show our brains actively construct our perception of time. So the central philosophical question becomes, what if time and consciousness aren't separate? What if they're deeply intertwined, maybe even two sides of the same coin? Could it be that the flow of time we feel, that subjective river, is actually the flow of consciousness itself?
That flips the whole thing around. Consciousness isn't in time. Maybe consciousness creates or is time?
That's the provocative idea, and it's not entirely new. Think back to philosophers like Immanuel Kant in the 18th century. He argued that time and space aren't things out there in the world, existing independently of us. He called them forms of perception.
Forms of perception.
Meaning they are the inherent structures of our minds. They're like the built-in operating system, or the lenses through which our minds have to organize any and all sensory experience to make sense of it. So we don't perceive time because it objectively exists. Rather, we perceive everything through the framework of time because that's how our consciousness is fundamentally wired.
So if there were no conscious minds to experience it, time itself, as a sequence, might not even exist.
That's the radical implication of Kant's idealism, yes. Time and space are contributions of the observer, not features of the observed world in itself.
Okay, how does that connect to the modern ideas we've been discussing?
Well, think about that projector analogy again. Consciousness might be taking this potentially timeless reality, maybe Barber's Nows or the block universe, and actively playing it out, frame by frame, creating the movie of sequential experience. Consider how your mind works right now. It's constructing this feeling of now, this present moment, which isn't infinitely brief but has a certain subjective duration, the specious present, psychologists call it. And your memory isn't just replaying a recording, it's actively reconstructing the past, often shaping it based on your current feelings or beliefs.
And anticipating the future is also an act of construction, based on past patterns and present goals.
Exactly. It all highlights the incredibly active, interpretive role of the mind. We aren't passive recipients of time's flow. We seem to be active architects of our temporal experience.
And some thinkers, like the cognitive scientist Donald Hoffman, take this even further, right, with his user interface theory.
Yes, Hoffman's idea is perhaps even more radical. He suggests that space and time are essentially like the icons on your computer desktop.
Okay, how so?
Well, when you use your computer, you click on icons, a folder icon, a document icon. Those icons aren't the reality of the complex code, the algorithms, the electricity flowing through the circuits inside. They're a simplified functional interface designed to help you interact with that deeper reality without needing to understand all the underlying complexity. They're useful tools for navigation.
So Hoffman is saying space and time are like those icons, not the real operating system of the universe.
Precisely. He argues that evolution has shaped our perceptions not to show us reality as it truly is, which might be vastly complex, maybe timeless and spaceless, but to provide us with a simplified, adaptive interface that helps us survive and reproduce. So the 3D space we perceive, the linear time we experience, they aren't reality itself, but a kind of virtual reality headset we're wearing, tailored for survival, a functional illusion.
That redefines everything we perceive as just a useful construct.
Wow. It's a profound idea. And interestingly, this notion that perceived reality, including time, might be a construct or illusion, isn't limited to modern science and philosophy. It echoes ideas found in many ancient spiritual traditions too. #, mysticism, time, and the eternal present. It's truly fascinating how these seemingly cutting-edge scientific and philosophical ideas resonate with insights from centuries, even millennia ago. The notion that time, as we normally experience it, might be an illusion Maya, or at least not the ultimate reality, is a recurring theme in many mystical and spiritual traditions worldwide.
Right. Like in Hinduism, you mentioned the idea of cyclical time, these vast Yugas, cycles of creation and destruction repeating endlessly, not a straight line.
Exactly. And within that, particularly in Vedanta philosophy, there's the core concept of Maya. This illusion isn't just about the physical world seeming separate and solid. It explicitly includes our perception of linear time and individual separation as veils obscuring a deeper, unified, timeless reality, Brahman.
And Buddhism, too, focuses heavily on time, or rather the present moment.
Immensely so. The concept of the eternal now is absolutely central. The past is seen as gone, just a memory trace in the mind, not existing anymore. The future is just a mental projection, a concept not yet real. So the only point of contact with reality is this present moment. And even that is incredibly fleeting, constantly arising and passing away.
Only now exists, and even that is elusive. I like that phrasing from the source.
It captures it perfectly. The practice is often about cultivating radical presence, detaching from regrets about the past or anxieties about the future, because fundamentally only this elusive now is where life happens.
And it's not just Eastern traditions. We have that powerful quote from Einstein again, after his friend Michel Besso died.
Yes, it's incredibly moving and relevant here. He wrote to Besso's family, "Now he has departed from this strange world a little ahead of me. That means nothing. For us physicists, the distinction between past, present, and future is only a stubbornly persistent illusion."
Coming from Einstein, the architect of our modern understanding of space-time, that statement carries immense weight. It connects the rigorous logic of physics with a deeply personal, almost mystical intuition about the nature of time and separation.
It really does, and it highlights this remarkable convergence. You have mystics arriving at these insights through introspection and meditation, philosophers through logical argument, and now physicists through mathematics and experiment. From so many different angles, the message echoes. Time may not be what we intuitively think it is. It might be far stranger, far more connected to our own minds than we usually assume.
Which brings us back to the practical implications. If time is an illusion, or fundamentally different from our experience, what changes? What does that actually mean for us? Hashtag, if time is an illusion, what changes? Yeah, this is where it gets really personal. After exploring all these mind-bending possibilities, relativity, neuroscience, quantum weirdness, philosophy, mysticism, what does it all boil down to? If time is generated by consciousness, or if it's part of a static block, or just a user interface, what does that mean for how we understand concepts like cause and effect, or free will, or even just change itself?
These are the profound implications we have to grapple with. Take cause and effect. We live our lives assuming A causes B, which happens later. But if time isn't linear, or if the block universe is real, is causality as fixed as we think? Does the effect maybe coexist with the cause in that block?
And the free will question looms large again. If the future already exists on that cosmic DVD, are choices just us playing out a pre-written script? Is free will itself the illusion, not time?
That's the classic deterministic challenge posed by the block universe. It's incredibly difficult to reconcile with our strong subjective feeling of making real choices that shape an open future.
And what about change? If reality is fundamentally timeless, or just a sequence of static nows, what does it mean for something to change, for a seed to grow into a tree, for us to learn and evolve?
Does change become just a different configuration existing at a different coordinate in the block? Is it just our consciousness experiencing different static frames in succession, creating the appearance of transformation? It challenges our very notion of progress and development.
So how can we even begin to think about this relationship between time and consciousness? Our sources suggested a few possibilities.
Right. Possibility one is that deterministic block universe view we just discussed. The future exists, free will is challenged. That's one way to interpret it. But possibility two flips it entirely. Maybe consciousness is so powerful it literally generates time as it experiences reality, like a flame lighting its own path, as the source poetically put it.
So consciousness as the active creator of the timeline, moment by moment.
Exactly. In this view, the future isn't fixed because consciousness is constantly bringing the next now into being out of a field of potentiality. This gives consciousness a truly central, active role in shaping reality. It preserves a sense of open future and agency.
Okay, what else?
Possibility three kind of inverts the usual framing. Maybe we've got it backwards, asking if time is in consciousness. What if consciousness is in time? Meaning, maybe time is a fundamental, real container or dimension, and our conscious experience simply arises within that pre-existing structure. Our perception of it might be subjective and malleable, but time itself is real.
So time is the stage, and consciousness is the actor on it, rather than the playwright.
That's a good way to put it. It keeps time fundamental, but explains our weird perceptions through the lens of brain function. And then there's possibility 4, which is perhaps the most encompassing and maybe the most humble. Maybe both time and consciousness emerge from something even deeper, a more fundamental level of reality that we don't have the concepts or tools to grasp yet. Perhaps they aren't separate things at all, but different aspects of, or emergent properties from, this underlying substratum. Two faces of a deeper unity.
So we're potentially dealing with something beyond our current understanding entirely.
It's certainly possible. We're pushing the limits of language and science here, which naturally leads us to ask, how is science continuing to probe these boundaries, especially with new tools like AI?
That's a great transition, because as we develop more and more sophisticated artificial intelligence, it forces us to confront these questions in a new way. How will these AIs perceive time? If we build a machine that can process information sequentially, learn from past data, and make predictions about the future, will it experience time like we do?
Fascinating question. Will it develop a subjective sense of flow, of duration, of memory having a pastness, and anticipation having a futureness?
Or will it just be incredibly efficient data processing? If an AI claims to have memories or makes plans, does that imply consciousness?
Or, conversely, could AI actually help us understand time better by showing us how complex temporal processing, remembering, predicting, sequencing can potentially be achieved through pure algorithms?
Could AI expose time as just another algorithm, as the source wondered, stripping away the subjective mystery and showing it as a computational process for organizing information?
It's a possibility. Studying how AI handles temporal data might give us new insights into how our own brains construct time, potentially revealing the tricks or mechanisms involved.
Meanwhile, physicists aren't standing still either. They're still tackling the big, unanswered questions about time.
Absolutely. There's ongoing, intense research into the arrow of time. Why does time only seem to move forward? The fundamental laws of physics, mostly, don't care about the direction of time. They work just as well forwards as backwards. So why the universal forward flow we experience?
Is entropy the key there? The tendency for disorder to increase?
That's a leading contender. The idea of thermodynamic time, that time's arrow is fundamentally linked to the universe becoming more disordered, moving from less probable states to more probable states, it gives time a statistical direction. But there are other ideas too. Some physicists are exploring whether time might emerge from quantum entanglement on a cosmological scale, that the very interconnectedness of quantum states somehow generates temporality.
So time isn't fundamental, but arises from quantum relationships.
That's the direction some theories are heading, trying to build time up from more basic quantum or gravitational principles, rather than assuming it as a starting point.
It seems like the more we investigate time from every angle,
the more elusive it becomes. As the source perfectly summarized, the more we investigate time, the more it slips through our fingers. It resists easy answers, constantly challenging our deepest assumptions. #outro personals.
So where does that leave us after this incredibly deep dive? We've journeyed through physics, neuroscience, quantum mechanics, philosophy, even mysticism, we asked. Is time an illusion? And the answer seems to be, well, it's complicated. It's not a simple yes or no. Perhaps the most honest answer we can take from all this is maybe. Maybe it is, in some profound sense. Or maybe reality is just far stranger than our categories of real and illusion can capture.
I think that's right, and perhaps the source material's final analogy is the most beautiful way to think about it. Maybe time is like a song with rhythm, flow, and emotion. But the song doesn't exist outside the listener. It's created in the act of listening.
That's lovely. Explain that a bit more.
Well, think about music. The notes on a page, the vibrations in the air, they're just physical phenomena. The song, the melody, the harmony, the feeling, the meaning that arises in the interaction between those physical signals and a conscious mind interpreting them. The experience of the song unfolds within the listener. It's co-created.
So if time is like that song, then our consciousness isn't just passively listening to the universe's tune.
Exactly. Perhaps our consciousness doesn't ride the wave of time. Maybe it is the wave.
Maybe our awareness is what gives reality its tempo, its sequence, its narrative quality, its meaning.
It positions consciousness not just as an observer, but as a fundamental participant, perhaps even a co-creator, of the temporal reality we experience.
A truly profound thought to sit with, which brings us back to you listening right now.
After hearing all this, what do you think? Is time something objective, out there in the cosmos, ticking away regardless of us? A fundamental feature of the universe?
Or is it something generated within us? An emergent property of our brains, our consciousness, a sophisticated illusion, a user interface, or the very song our awareness sings?
There's no single right answer here, certainly not yet. It's one of the deepest mysteries.
We would genuinely love to hear your perspectives. What resonates with you? Let us know in the comments on our website or reach out on social media. And if this deep dive bent your perception, even just a little bit, if it sparked some new questions about your own experience of time, please share it with someone else who enjoys pondering the big, beautiful, baffling questions about existence.
You're wondering.
Until next time, keep looking up, keep questioning, and always remember, the cosmos is vast, undeniably mind-boggling. But perhaps the greatest mystery, the ultimate frontier, isn't just out there among the stars, but might actually lie deep within your own mind.